Hi, good afternoon, everyone. So we'll start with today's lecture. Today's lecture is part 3 of Neuroradiologic Anatomy. We've already covered the spine. So today we're going to start with the brain itself. We're going to be covering the anatomy related to MRI images and under 3 sections. There is the axial, sagittal, and coronal sections. Before we get into the anatomy of the MRI images itself, let's just have a very quick overview of some basic anatomic findings in a normal brain. So if we do that, we'll just be able to understand the images much quicker. So we know there's a frontal, parietal, occipital, and temporal lobe, and the different gyra and sulci which are present within these lobes. Hopefully, we're all aware of that by now. But just as a quick revision, so in the frontal lobe, that extends up to the central sulcus posteriorly. Within the frontal lobe, you have a dorsolateral surface which has a superior frontal gyrus, the middle frontal gyrus, and the inferior frontal gyrus. And you have the superior frontal sulcus and the inferior frontal sulcus, right? So this is here the central sulcus, and this demarcates the frontal and the parietal lobe, in front of which you have the precentral gyrus, which is your motor cortex, and behind which you have the postcentral gyrus, which is the sensory cortex. And behind this, you have the superior parietal and the inferior parietal lobule. The inferior parietal lobule has a supramarginal gyrus into which your sylvian fissure ends. And then you have the angular gyrus into which your superior temporal sulcus ends. The temporal lobe on the dorsolateral surface has 3 gyri, the superior temporal, the middle temporal, and the inferior temporal gyrus, with 2 sulci, which are the superior and the inferior temporal sulcus, right? And then further posteriorly, you have the demarcation between the occipital lobe and the parietal and the temporal lobe. That is through an imaginary line which connects a preoccipital notch located over here. And the parieto-occipital sulcus, which is present over here. So this demarcates your parietal and temporal lobe from the occipital lobe. The occipital lobe has multiple gyri, none of which are significantly named. The other important thing is the inferior frontal gyrus on the dorsolateral surface has 3 important parts. You have a pars triangularis, which is over here. You have a pars opercularis, and then you have a pars orbitalis, which is anteriorly located. So the sylvian fissure comes and divides these different parts using a anterior ramus and an ascending ramus. So first you have the orbitalis, then you have the triangularis, and then you have the pars opercularis. The pars opercularis on the left side is a Broca's area. Apart from the superior temporal gyrus, on its opercular surface also has a planum temporale and a planum polare, which is located on the opercular surface. And on the medial side of that, you'll get a Heschel's gyrus, which is the vernix area. Right, so this is the same thing looking from the superior surface. You have the superior frontal gyrus, quite obvious over here. Then you have this central sulcus, which is the only sulcus to be reaching the midline. Then you have this precentral gyrus, the postcentral gyrus, and the other gyri that we've already discussed. On the inferior surface, on the other hand, we can see all the other different structures we have not yet discussed. So on the inferior surface, the frontal lobe has a gyrus rectus. It also has these multiple orbital gyri, which are divided by this H-shaped sulcus, which divides it into a medial, anterior, lateral, and posterior olfactory gyri. And then in between the gyrus rectus and the medial olfactory gyrus, you have the olfactory sulcus in which the olfactory nerve runs. Okay, apart from that, you also have the temporal lobe present on the inferior surface. The temporal lobe is slightly complicated, but the important things to remember are, on the lateral part, you have the inferior temporal gyrus. And on the medial surface, you have the parahippocampal gyrus. Between the parahippocampal gyrus and the inferior temporal gyrus, you have the fusiform or the occipitotemporal gyrus. The occipitotemporal gyrus is separated from the parahippocampal gyrus by the collateral sulcus over here, and from the inferior temporal gyrus by the occipitotemporal sulcus over here. Okay, and then apart from that, at the medial edge of the parahippocampal gyrus anteriorly, you have the uncus, which is going to be very closely situated to the midbrain and to the cerebral peduncle over here. This is a view from posteriorly. You can see the occipital gyri. This will be the parieto-occipital sulcus. This will be the tentorium over here. This is the occipital lobe. No significant gyri which are present on the lateral surface. This is another very important anatomy for all the deep structures that are located within the brain. So we have to remember that a lot of these deep structures are C-shaped. So a lot of them start from anteriorly and then they wind around and then they become C-shaped. So that helps to remember its anatomy quite a bit. So that includes your ventricle, that includes the fornix, and that also includes the corpus callosum as well as the choroid nucleus. All of these structures are C-shaped structures. So we can see a lot of them here. So you've got the fornix, which is green over here. You've got the caudate nucleus, which is white over here. Above that, you'll also have the corpus callosum, and then you have the lateral ventricle. Right. So this, this is a slightly complicated anatomy, but if you can understand this image, it'll be quite helpful for the MRI images as well. So as you can see over here in the center, you have the corpus callosum, below which you will have the lateral ventricle. The lateral ventricle has 4 important parts. You have the frontal horn, you have the body, you have the atrium, and then you have the temporal horn. You also have an occipital horn which arises from the atrium and runs posteriorly. So the corpus callosum covers the body as well as the atrium of the lateral ventricle. The corpus callosum has a geno over here anteriorly, then it has a body, and then it has a splenium posteriorly. The geno will bend down and form a rostrum anteriorly in front of the lateral ventricle frontal horns. The caudate nucleus also wraps around along with the lateral ventricle and forms a part of the walls of the lateral ventricle. It also has a head, a body, and a tail. The fornix, on the other hand, arises from the hippocampus, okay, and then it again wraps around the lateral ventricle as well. So here it forms the columns of the fornix, and then there's a hippocampal commissure here connecting both the fornices. Then it forms the bodies, and then it forms the pillars, the anterior pillars which are present over here. Right. So on the medial surface, the anatomy is a little bit different as to what we have discussed so far. On the medial surface, the central sulcus does not extend. On the other hand, you do have a paracentral lobule over here, which is located between the anterior border of the pars marginalis over here. Just anterior to that, you have the paracentral lobule, and then you have the paracentral sulcus over here. That is where the paracentral lobule is located. Behind that, you have the precuneus, and below the calcarine sulcus, you have the cuneus, which is part of the occipital lobe. So an important structure on the medial surface is this calcarine sulcus. Apart from that, also the pars marginalis, which is the upturned border of the cingulate sulcus. So you have the cingulate sulcus over here, which turns up and forms the pars marginalis. Below that, you have the cingulate gyrus over here, below which you get the corpus callosum. You have the septum pellucidum separating both the lateral ventricles, and then here you have the fornix, below which you have the choroid plexus over here. This is the third ventricle below the fornix, which is bordered by the thalamus on both sides. This is the massa intermedia over here, and this is the location of the hypothalamus. This is the optic chiasm, and this is the pituitary gland. Posteriorly, in the third ventricle, you have the pineal gland, you have the tectum over here, the aqueduct over here, the pineal recess, and then in the borders of the pineal gland, you have the habeneural commissure and the posterior commissure. The habeneural commissure will be located superiorly, and the posterior commissure will be located inferiorly over here. So this is a slightly closer up view, so you can make out there are 2 very important commissures when it comes to imaging. The anterior commissure, and over here you will find the posterior commissure. These will be very obvious structures on imaging, and as we go on with this lecture, we'll see how these can be seen. Apart from that, we've already discussed the region of the hypothalamus, the third ventricle. This is the optic chiasm, the supraoptic recess. You have the infundibular recess. This is the floor of the third ventricle. You should also have the mammillary bodies that are located over here. And then this is the tegmentum of the midbrain. Right. So now let's discuss the MR imaging itself and how we can identify what are the different anatomic structures on axial images. Okay, so this can be slightly difficult, but if we follow a couple of rules, it's quite easy to identify what we're looking at in most of the situations. So in all of these images in this lecture, the T1 image without contrast will be on the left side, and that's what we're using to describe the anatomy because the anatomy is more clearly seen on T1 images. And then the T2 images will be on the right side. I don't think it's necessary for me to describe the basics of MRI at this moment, but just as a reminder, on T1, gray matter will be gray and white matter will be white. On T2, gray matter will be white and white matter will be gray. Okay. So, in this with the axial imaging, we're going to be starting from as superior as possible and then going down inferiorly. So in this, the different structures that we can identify, this right here is the superior sagittal sinus. This is the fox. Okay, and this is a quite high up image. And the higher up we are, the the largest part of the brain will be occupied by the frontal lobe. Okay, so here we can see a sulcus which is reaching the midline. So if this sulcus is reaching the midline, it has to be the central sulcus. Correspondingly, on the other side, this sulcus corresponds to this sulcus. So this on the other side will be the central sulcus. So far we have been able to identify the central sulcus. Using that, we can identify that this is the precentral gyrus and this is the postcentral gyrus. Another way to identify these two would be using the thick and thin sign. The precentral gyrus will always be thicker and the postcentral gyrus will always be thinner. So that also helps you to identify these structures. So the central sulcus will reach the midline, and then the precentral gyrus and the postcentral gyrus are thick and thin. Right. So we know that anterior to the precentral gyrus, so superiorly, you would only have the superior frontal gyrus. So this entire thing is superior frontal gyrus. This here is the superior middle frontal gyrus, and this is the superior frontal sulcus. Precentral gyrus, postcentral gyrus. This here, behind the postcentral gyrus superiorly, is the superior parietal lobule. In the next cut, we're able to still see the superior sagittal sinus. You've still got the fox over here. This continues to be the superior frontal gyrus. This is the middle frontal gyrus. This is what is known as the omega sign. This omega sign is the sign corresponding to the hand motor region on the motor cortex. So this is a very easily identifiable sign on both sides. This is also the omega sign on the other side, and this on this side. So this helps you identify that this again is the precentral gyrus over here. The omega sign usually comes at the level of the middle frontal gyrus. Okay. Also posteriorly, the omega sign usually comes at the level of the inferior parietal lobule. Okay, so when you have the hand motor sign, anteriorly you will find the middle frontal gyrus, and posteriorly this is the inferior parietal lobule. This is the superior parietal lobule, and this is the inferior parietal lobule. This is the medial surface. The medial surface corresponding to the precentral and the postcentral gyrus. So this over here represents a paracentral lobule over here. Okay, and we know the paracentral lobule is going to end posteriorly on the interhemispheric surface in the marginal sulcus, which is the upturned end of the cingulate sulcus. That is identifiable over here. Okay, so in the next cut, we can stick with some of the things we've discussed in the previous cut. This will be the superior frontal gyrus. Okay, this will be the next gyrus will be the middle frontal gyrus, and the next gyrus to that. Here, we have not yet reached the inferior frontal gyrus. Okay, so this can be slightly confusing. A way to figure out what gyrus this would be to again look for the thick and thin sign. So over here you can see this gyrus is quite thick and this is quite thin. So it helps you to identify that this is actually the motor cortex and this is the sensory cortex. So this is the precentral gyrus, this is the postcentral gyrus. Behind the postcentral gyrus, since this is not right at the top, this would likely be the inferior parietal lobule. Inferior parietal lobule would consist of, in this region, mostly the supramarginal gyrus. If you come slightly more posteriorly, this will be the angular gyrus over here. Behind that, since we are still most likely in the parietal region and not in the occipital region, this would not yet be the cuneus, but as we go down, this posterior region will start becoming the cuneus. This region, this whole area of white matter, it's a centrum semiovale, which is basically the white matter fibers running from the entire hemisphere down to the internal capsule. Okay. Now coming further down, again, we have the superior frontal gyrus, we have the middle frontal gyrus. We have not yet reached the inferior frontal gyrus. Okay, so again, using thick thin sign, we are able to identify that this is the precentral gyrus and this is the postcentral gyrus. Behind the postcentral gyrus, we'll again have the supramarginal gyrus and we'll have the angular gyrus. Again, we have not yet reached the occipital lobe, and the way to identify the occipital lobe would be when we reach the atrium. Until we reach the atrium, we don't consider that this region is the occipital lobe. So this is still the parietal lobe itself, probably the region of the precuneus. Okay, and this is the angular gyrus and this is the supramarginal gyrus. This structure, this very plain, simple looking structure on the medial surface is the cingulate gyrus. This sulcus anterior to the cingulate gyrus is a cingulate sulcus. So this you can see is a cingulate gray matter. The cingulate sulcus will be running above the cingulate gray matter. There are basically sheets of arachnoid which sometimes extend along blood vessels and form dilated spaces running around blood vessels, and these are called the Virchow-Robin spaces. And there are times when you can see these in imaging. They appear as T2 hyperintensities and T1 hypointensities, so like over here and over here. So these are known as Virchow-Robin spaces. Nothing abnormal about them. These are normal findings in MRI. Okay, coming to a cut lower. So again, the first gyrus you will see here is a superior frontal gyrus. Okay, just remember that the superior frontal gyrus extends all the way from superiorly up till inferiorly. That is why through all these cuts, the first thing we're seeing is a superior frontal gyrus. At any level of cut, the first thing you would see is a superior frontal gyrus. Okay, this is the superior frontal gyrus. This is the middle frontal gyrus. Over here, again, we have still not encountered the inferior frontal gyrus. Once you encounter the inferior frontal gyrus, you would also probably see a part of the Sylvian fissure. So this over here is the precentral gyrus. As we start coming down, the precentral gyrus becomes thinner and thinner. So it can be a little difficult to differentiate at this point between the precentral and the postcentral gyrus. This is the postcentral gyrus and this is the precentral gyrus at this level. Okay, and if you come down posteriorly at a lower level, this will be the supramarginal gyrus and this will be the angular gyrus. Okay, this now we have started seeing a very obvious sulcus over here on the medial surface, and we know that on the interhemispheric surface medially, the most obvious sulcus posteriorly is the calcarine sulcus. So this is the calcarine sulcus. Once you start seeing the calcarine sulcus, you know what is present below that is going to be your occipital lobe. So all this region is now the occipital lobe. This is the cuneus. At this cut, we're now starting to see the lateral ventricle. So this is the body of the lateral ventricle. And the structure running between both the bodies of the lateral ventricle is the body of the corpus callosum. Okay, so the next step we have gone a little bit more inferiorly and we're able to see more obvious structure. So this lateral ventricle has become clearly demarcated now. So you can make out the body of the lateral ventricle quite nicely now. There's some gray matter which runs on the side of the lateral ventricle, and this is the caudate nucleus. The caudate nucleus anteriorly will have a head, and then in the middle along the body of the lateral ventricle it has a body, and then it has a tail which wraps around and enters a temporal horn. Okay. Then again, we have the same structures that we did before. You have the superior frontal gyrus, you have the middle frontal gyrus, and now you also have the appearance of the inferior frontal gyrus over here. This is your precentral gyrus and this is your postcentral gyrus. Okay, again, posteriorly, we have some obvious structures. And this very obvious sulcus present on the interhemispheric surface is the calcarine sulcus. Okay, so when it comes to the calcarine sulcus, there's a few important things to remember. At the level of the calcarine sulcus, whatever is located behind is usually the cuneus, and whatever is located anteriorly would be the cingulate gyrus. So this here is a cingulate, and this here is the cuneus. There's a structure we can see over here on the T2 image a lot more clearer than we can see it on the T1 image. You can see it on T1 also. T1 also it is hypointense, and T2 also it is hypointense. So this structure is nothing but your ACAs. Okay, so all blood vessels will appear hypointense and well demarcated and round structures on cross-sectional imaging, which is T2 weighted. So here you can see the ACAs running within the intrahemispheric fissure. So these are the other blood vessels. So you can see all the blood vessels are T2 hypointense. These are subependymal veins which are running below the ependyma and the lateral ventricle. Okay, so coming to one more cut inferiorly. There are a few important things to pick up on this slide. So we can see that the lateral ventricle is becoming a little bit more clearly demarcated. We're able to see this structure, which is the choroid plexus within the lateral ventricle. You have the body of the lateral ventricle, you have the frontal horn of the lateral ventricle, and as we've discussed, we have the gray matter lying next to the lateral ventricle. This is the caudate nucleus. Okay. This here is demarcating our precentral and postcentral gyri. This is the superior frontal, middle frontal, and inferior frontal gyri. Okay. Apart from that, we've already discussed, this is the calcarine sulcus. In front of the calcarine sulcus, this simple rule is cingulate in front and cuneus behind. Okay, so that is very easy to remember. And another thing that we can pick up on T1 imaging is this T1 iso-intense structure. That is a temporalis muscle. Okay, so apart from that, we also have some slightly complicated structures over here. So this would be still the splenium, or basically the corpus callosum and the splenium over here. Here you have two structures which are wrapping around this T1 hypointense structure. This T1 hypointense structure is actually the superior border of the third ventricle. And these two structures are wrapping around it are the fornix. This here is a septum pellucidum. This is the fornix. Okay. And this is the third ventricle roof. Okay. So coming to the next level, slightly more inferiorly, you have a few hopefully now clearly more identifiable structures. Again, you have the superior frontal gyrus here, the middle frontal gyrus here, and the inferior frontal gyrus over here. Now the sylvian fissure has become a lot more obvious and demarcated. Okay, so this whole structure is the frontal operculum, which will include your pars triangularis and pars subarticularis. Below which you have the insula. Over here is the insular cortex. Okay. At this point, now that you've reached the sylvian fissure, you will not have the precentral and the postcentral gyrus anymore. Below the sylvian fissure, in this direction, you'll start now getting the temporal lobe. This is the superior temporal gyrus, and this is the middle temporal gyrus. Behind that, you will have the occipital gyri over here. So this is the occipital gyrus. Okay. Apart from that, other very obvious identifiable structures, again, we can still see the calcarine sulcus over here. And behind the calcarine sulcus, as we know, this is the cuneus. In front of the calcarine sulcus, you will have the So at this level, what happens is that the calcarine sulcus actually forms two stems. So these are two stems of the calcarine sulcus over here. So just to make this clear, one second. Yeah, so at this level, the calcarine sulcus has two stems. So in front of the anterior stem of the calcarine sulcus, this area is the cingulate. This area is the lingual gyrus, and this area is the cuneus. So this is one stem of the calcarine sulcus, and this is one more stem of the calcarine sulcus. In between the two stems, you have the lingual gyrus. In front of the anterior stem, you have the cingulate, and behind the posterior stem, you have the cuneus. At this level, basically the level of the atrium, the cingulate forms a structure known as the isthmus. The isthmus connects the cingulate gyrus to the parahippocampal gyrus. So this is the region of the cingulate isthmus. So you can help pick that up with the level of the atrium. So at the level of the atrium, you'll have two stems of the calcarine sulcus. You'll have the cingulate isthmus, and you'll have the lingual gyrus located over here. So we've picked up on the atrium. There's the choroid plexus of the atrium. This is the splenium over here. This is the third ventricle. These structures that we can see running within the third ventricle are the internal cerebral veins over here. These ones. So these are, as we know, vessels are a lot more obvious when it comes to T2. So we can see these very hypointense structures running within the third ventricle. That is your your internal cerebral veins. Posteriorly, you can see another very obvious hypointense structure, which is running posteriorly. This would be the vein of Galen over here. Okay. Another structure you can pick up on over here is the foramen of Monro, the place where the frontal horn would open into the third ventricle. These slightly hypointense structures are basically the fornix, the anterior columns of the fornix. Okay, and this here is the genu of the corpus callosum. And this region. Okay, another structure which is a C-shaped structure is your cingulate gyrus. The cingulate also wraps along with the corpus callosum. So you have the cingulate posteriorly over here, but you also have the cingulate anteriorly. So another obvious structure anteriorly would be the cingulate sulcus, and then just below that you have the cingulate gyrus over here. Okay. So when we come lower down, we have the same very obvious thing. You have the Sylvian fissure over here. You have the insular cortex. You have the above the Sylvian fissure. This is all frontal lobe, and this is all temporal lobe. This very obvious gyrus which is standing out, this is the Heschel's gyrus. This is part of the temporal lobe. You have the frontal horns. You have the septum pellucidum present over here. This is all the fornix, the anterior pillars of the fornix. This is a very obvious foramen Monro over here. This is the thalamus. This structure over here. So to know exactly what it is again important to look at the T2, and notice it is quite hyperintense. So this is again the internal cerebral vein. And this here is the vein of Galen. This is the splenium of the corpus callosum. This is the calcarine fissure. This is another stem of the calcarine fissure. So this will be a lingual gyrus. This will be an isthmus of the cingulate, and this will be a cuneus. This here is the occipital horn, the atrium. Okay. And this here is your quadrigeminal system. Okay. So at the next level, you have, as you can see, as we go down and more inferiorly, the lateral ventricle starts disappearing. We are now able to see a little bit more of the third ventricle and lesser of the lateral ventricle. And more as we come across the third ventricle, we start seeing more of the thalamus and the basal ganglia. So that's what becomes important in this region. You still have the superior frontal gyrus, the middle frontal gyrus, and the inferior frontal gyrus over here. You have the insular cortex, you have the frontal operculum, you have the Heschel's gyrus over here, and then other temporal gyri located behind it, the superior, middle, and the inferior temporal gyrus. This all would be the occipital horn. This is the level of the atrium and the occipital horn over here. This is the quadrigeminal cistern located over here. Okay, so all these things we've discussed and hopefully been able to understand so far. Okay, this here, this very bright, very obvious thing on T1 is the habenular nucleus. Okay, and these are the columns of the fornix. This another very bright thing over here is going to be the anterior commissure. Okay, so both the commissures, your anterior commissure and the posterior commissure, are quite bright on T1 and they'll be very easily identifiable. Right, so you can see both of them very clearly in this image. This here is the anterior commissure, again T1 bright, and this here is the posterior commissure, which is also T1 bright. Okay, and they're quite hypo on T2. So this is the anterior commissure and this is the posterior commissure on T2. Okay, we have come more inferiorly, so we're now able to clearly make out the third ventricle over here. Okay, so now at the level of third ventricle, we do not have the obvious frontal gyri anymore. We do not have the superior frontal and the middle and the inferior frontal gyri anymore. Now we have this gyrus rectus. This would be the cingulate over here, the cingulate sulcus over here. Okay, this here is known as a subcallosal area. Okay, so this would be the area of the medial frontal hemisphere located below the corpus callosum. So on the medial surface, you'll first get the superior frontal gyrus a little bit. Okay, then you will get the cingulate, and then you will get the subcallosal region. Okay, so then you have the temporal gyri located over here. These are your superior, middle, and inferior temporal gyri over here. You have the insular cortex here and the very obvious Sylvian fissure over here. Okay, so now those are the things we already know. Apart from that, what are the important things to pick up is this here is the caudate. Right, so this is the caudate head over here. Okay, and then behind the caudate head, we'll start seeing some very obvious structures. So this is the anterior limb of the internal capsule. This here is the putamen. Next to the putamen, you can see some white matter, and then again some gray matter, and then again some white matter. So that'll be external capsule, your claustrum, and your extreme capsule. Okay, so again you can see it here. This is the putamen, this is the external capsule, the claustrum, and the extreme capsule next to that. There are some other very less obvious gray matter structures, which are your globus pallidus interna and externa. To correspond, you can see they appear more hypointense or T2. So you can see them here, the globus pallidus externa and interna. Next to the globus pallidus interna and externa, here, so this is the anterior limb of the internal capsule, and this will be the posterior limb of the internal capsule over here. The thalamus is not very obvious, but in the next cut, it should be. So the thalamus would form over here. This right here is the region of the pulvinar. Okay. Apart from that, here, we are also seeing a very important gray matter structure, okay, which is located along the medial border of the atrium over here. This is the junction of the atrium and the temporal horn. So this is actually the tail of the hippocampus, located over here. Okay. And behind the tail of the hippocampus, here, this is the cingulate isthmus, part of the calcarine. This is the lingual gyrus, and then you have the cuneus over here. Same thing. This is the calcarine. This is the cingulate. This is the lingual, and then you have the hippocampal tail over here. Okay, so in the next cut, we have gone further down and we're able to make out a few more structures, which are important. So here, we can see this very long gyrus. This is your gyrus rectus. Or the lateral gyri, which is this now, we're coming close to the ACF base. So this will be your olfactory gyri, the middle, the medial, the lateral, the anterior, and the posterior olfactory gyri. We don't already have to identify any of them individually, but the gyrus rectus is important, which is over here. You have the Sylvian fissure, the insular cortex, the temporal gyri, and the region of the occipital gyri. Okay. Apart from that, there are a few more important things. There are these T1 hypointense and T2 hypointense structures located in the intrahemispheric fissure. Those are ACAs. Next to the ACAs would be your cingulate gyrus located over here. Okay. And then you have the region of the anterior commissure. You have this caudate nucleus over here, and you have, the caudate does not exist in this level. So this here is the putamen. Okay. And then you have the third ventricle located over here. This is the midbrain with the aqueduct and the superior colliculi located over here. This would be the region of the cerebral peduncle on both sides. Okay, and there are a few structures you can make out more clearly on a T2 image at this level. So one of them is the red nucleus, which is very clearly seen here. And then you have the subthalamic nucleus also, which is very clearly seen here. Okay, now coming to the next cut. At the next cut, there are a few important things that we have to pick up at this level also. So, the putamen will actually end up connecting to the amygdala in the temporal lobe, okay, through the temporal stem, and the putamen will also connect to the globus pallidus through a nucleus inferiorly. That is the nucleus accumbens. That is what is located over here. So this region is the nucleus accumbens. Okay, so here we can make out the Sylvian fissure. This is all frontal lobe, gyrus rectus, your olfactory gyri, all temporal lobe, and your occipital lobe. Okay, this is the midbrain that we have made out. This is the aqueduct over here with the periaqueductal gray. This will still be at the level of the superior colliculus. This here is the nucleus accumbens. There are a few T1 hyperintense structures that we are seeing running horizontally. So this one is the anterior commissure, and this other T1 hyperintense structure running just between the midbrain and the cerebrum is your optic tract. Okay, so here is one. This is the anterior commissure, and this is the optic tract. Similarly, you can see on T2, this optic tract is hypointense and the anterior commissure is hypointense as well. On T2, you're able to make out more clearly what is the red nucleus, the cerebral, the crus cerebri, and the subthalamic nucleus over here. Okay, so now coming to cuts lower down, which help us describe the anatomy of the medial temporal lobe and the region of the uncus. So this, a lot of very important structures in here. So now we're able to clearly make out the optic tract. that we saw in the previous image. So this is the optic tract, this one on both sides. This is the floor of the third ventricle. So these round structures are your mammillary bodies. This T1 iso-intense structure would be your hypothalamus. Okay. So these are your suprasellar cisterns located over here. This is at the level of the inferior colliculus over here. This is the midbrain. And the slightly hypo-intense structure separating the crus from the tegmentum is the substantia nigra, which you can see also on the T2 image. Here, this hypo-intense structure is the substantia nigra. Similarly, so this hypo-intense structure is the optic tract. This is the mammillary body. And this is the hypothalamus. These will be your ACS running over here. While this in the Sylvian fissure would be your MCS. This here is the cerebellum sticking out above the 10th. So this part of the cerebellum is known as the culmen. Okay, coming one further cut down, we're able to see a few changes now. The midbrain is turning a little bit more into the shape of the pons. Apart from that, the optic tract, when it comes anteriorly, it forms the optic chiasm and then the optic nerve. So we're able to see the optic nerves and the optic chiasm over here. Behind the optic chiasm, this very round, important structure is the infundibulum, forming the pituitary gland as it goes down. This here is, as we've already discussed, is the T1 hypointense structure. There's a substantia nigra, and this is the crus. Apart from that, we're also able to see the structure of the medial temporal lobe. So we know that this structure in contact with the cerebral peduncle is the uncus. The uncus has an anterior border, and then it has a posterior border. Along the anterior border, you have the amygdala over here. This here, along the temporal horn, is your hippocampus. So, you will identify the amygdala and the hippocampus on axial imaging now. This will be the gyrus rectus and the other olfactory gyri, and this is your superior aspect of the orbit. On T2 imaging, you'll be able to see the vessels more clearly. So this is your ICA here, which here is divided and given rise to the MCA on both Sylvian fissures. This is most likely the PCA. Okay, so further one level down, we're able to see a little bit more detail. This is your optic nerves running into the orbit anteriorly. You have the uncus, the amygdala, the hippocampus over here. So easy to identify, just remember that the uncus is a triangle. It has an anterior border and a posterior border. At the level of the anterior border, you have the amygdala. At the level of the posterior border, next to the temporal horn, you have the hippocampus over here. So that's how you can differentiate between the hippocampus and the amygdala and easily locate them. Okay. Then here is the beginning of the fourth ventricle and the cerebral aqueduct. And there's a very T1 iso-intense structure located over here. So this is your transverse sinus. You can compare it with T2 imaging. It is quite hypo-intense on T2. So this is the transverse sinus and not part of the occipital lobe itself. Okay, coming further down, you have the orbit, the eyeballs. This is at the level of the vitreous. Lens is not clearly seen here. You have the orbital fat being very obviously hyper-intense on T1 imaging. We'll discuss the orbit separately in a different class, so no need to go into detail about that. We have, I think previously, so in this level, we're now able to see the cavernous sinuses on both sides. Located over here. And in between the cavernous sinuses, here we have the sella turcica. Okay. Now we have gone further down and some of the structures which we were able to see previously are not as obvious now. So here you have the amygdala. Here you have the hippocampus, and this is the parahippocampal gyrus. This T1 hyper-intense structure that you're able to see running along the temporal lobe, which is also T2 hypo-intense, so that is dura, that is basically your tentorium cerebelli. This here has now changed from the midbrain to the pons, okay, and this structure running between the pons and the cerebellum is your superior cerebellar peduncle. Okay, so here now we're able to make out much more clearly the cavernous sinus located over here. as we go further down. And within the cavernous sinus, there's this very obvious T2 hypointense structure that is the cavernous ICA located over here. Okay, the pons is you could very easily identify that this is the pons because it forms a bridge. So it'll always have a full connection with the cerebellum. These are your optic nerves on T1 on both sides. This is on T2. You can also see a T2 hyperintensity surrounding the optic nerve. That is the optic nerve sheath containing CSF. When you come further down, you'll finally encounter the region of the Meckel's cave. So this region, always just sometimes people can find it difficult to localize the Meckel's cave and the fifth nerve. The first thing is identify that you're at the level of the pons. Okay, make sure that you're seeing this bridge-shaped structure. Okay. Second thing, look just behind the cavernous sinus and just medial to the medial border of the temporal lobe. So right here, you'd find the Meckel's cave. Over here, we can see that the trigeminal nerve is running from the brainstem into the Meckel's cave over here. When we go further down, now we can very clearly see the Meckel's cave. This is the T2 hyperintense Meckel's cave. Okay, but this is at the level of the 7th, 8th complex. We're not seeing the 5th nerve over here. So this is the 7th, 8th nerve over here running into the internal acoustic canal on both sides. Same thing, you can see the nerves also on T1 as well. This structure over here is the facial colliculus protruding into the 4th ventricle posteriorly from the brainstem. Okay, so again, this is the Meckel's cave, T1 hypointense because it is CSF, T2 hyperintense, that is all the CSF of the Meckel's cave. Right. Okay, at this level, the pons starts narrowing again and is starting to convert itself into the pontomedullary junction. That is why the connection between the cerebellum and the pons will start narrowing and becoming less bridge-like. So that's when you know it is turning into the medulla. This here is your 8th nerve entering the internal acoustic canal. This is the 7th nerve over here. This is the pons. Okay. This here is a cerebellar verbus. This is the sigmoid sinus over here. Okay. So at the next level, now the pons is starting to form the medulla. Okay, so this part is going to become the medulla. This is the pontomedullary junction. This part is the vestibular area of the medulla. This is the inferior cerebellar peduncle. This again is still showing the 8th nerve to an extent, and this is the cerebellar verbus. As you go down, you have to keep track of how the pons changes into the medulla and how the midbrain changes into the pons. And what are the different nerves you can pick up? So you can pick up 5th, you can pick up 7th, you can pick up 8th. Right, so at this level now, the pons has formed the medulla. So you can see there's no connection between the structure and the cerebellum. So you can easily pick out that this is the medulla. At this level, we'll find out a few important structures that you can make out on imaging. So one of these here is the pyramid. This is one obvious prominence here. The next prominence is the olive. In front of the olive, the pre-olivary sulcus, and then you have the post-olivary sulcus. This will be the nucleus gracilis and the nucleus cuneatus located posteriorly. This is the foramen magendi. These are cerebellar tonsils located medially. Okay, and this is the space between the cerebellar tonsils known as the vallecula. That is the vallecula. This is the space through which we carry out the tilovelotonsillar approach. As you come further down, we're able to see that we're entering slowly the region of the foramen magnum. So this almost at the region of the foramen magnum, we're able to make out this is the medulla. It's trying to turn into the spinal cord now. And only the cerebellar tonsils are left behind the medulla. There's also a T1 and T2 hypointense structure running next to the medulla. So those are your vertebral arteries over here. Right. So that provides us a good idea of all the different structures we can identify on MR imaging. And axial imaging is what we usually look at when we're looking at MRI imaging. And so if we get a very good familiarity with the axial images, we'll be able to pick up most of the anatomy using that itself. But sometimes you need to pick up this anatomy on sagittal or coronal images as well. And it is possible to pick it up on these images. Sagittal is quite easy because we don't have to discuss both sides because it is symmetric. So we'll just discuss one side and see what are the different structures we are able to identify. So this is a sagittal T1 and T2 image. The most obvious structure that we can see over here is a Sylvian fissure. This will really help pick out a lot of different structures that we can identify on sagittal imaging. So no need to get worried about this. Just pick up the Sylvian fissure, that is first. And the second thing is pick up the tentorium, which is over here. So this is the transverse sinus and this is the tentorium. Okay, so once you have picked these up, a lot of the other structures become quite obvious and quite easy. Remember that we are quite laterally. Okay, so this is the first cut from the lateral surface. So at this point, we're not really going to see the superior and the middle frontal gyrus. We'll only be seeing the inferior frontal gyrus. So that's what we're seeing here. So this is your frontal lobe. Above the Sylvian fissure, we're seeing the inferior frontal gyrus. This triangle-shaped structure is the pars triangularis. So anterior to that, we have the pars orbitalis. And posterior to that, we have the pars orbicularis. Okay. We also have a sulcus over here, which is not really reaching the Sylvian fissure. And that's what usually happens with the central sulcus. It does not reach the Sylvian fissure. It always leaves a small U-shaped band of cortex below it, which is known as subcentral gyrus. So this is the precentral gyrus, which is thick again. This is the postcentral gyrus, which you can make out as thinner. This is subcentral gyrus located below the central sulcus, around the Sylvian fissure. You have the postcentral gyrus. This will be the parietal lobe. The parietal lobe, the part of the parietal lobe which wraps around the Sylvian fissure is known as the supramarginal gyrus. And behind that, the part wrapping around the superior temporal sulcus over here. This is your angular gyrus. Okay, so there's a lot of things you can actually make out even on such images. We're able to see orbitalis, triangularis, opercularis, the precentral, the subcentral, the postcentral, the supramarginal, the angular. Here it's a superior temporal. Then this very obvious gyrus which is sticking out is going to form the Heschel's gyrus in the next few cuts. Okay, so this is superior temporal gyrus, this is the superior temporal sulcus, this is the middle temporal gyrus over here, and this is the inferior temporal gyrus over here. Okay. So in the next cut, as we go deeper, you can still see some of the same structures. You have the triangle, which is the triangularis. You have the orbitalis. You have the opercularis. Now you will also able to see a little bit of the middle frontal gyrus. You still have the thick and thin sign to identify the pre and post central gyrus. You have the another way to identify the pre and the post central or sagittal imaging. When we just look at the Sylvian fissure. The Sylvian fissure will go and end posteriorly into the supramarginal gyrus. So this is the supramarginal gyrus. Just anterior to the supramarginal, you should have the postcentral, and then anterior to that, you have the precentral gyrus. This here is the angular gyrus. This here is now formed the Heschel's gyrus. The superior temporal gyrus, middle temporal gyrus, and inferior temporal gyrus over here. As we go further, more towards the midline, we're able to see a little bit more important structures. Now we're able to see the insula. There's a Sylvian fissure and the insula is now obviously seen. You can use the thin and thick sign again to identify that this is the precentral gyrus and the postcentral gyrus over here. Again, where the Sylvian fissure is ending is the supramarginal gyrus. So another way to identify the pre and the postcentral gyrus as well. On T2 imaging, we can see all the M2 MCA branches running within the insular cistern. In the next more medial cut, we're able to see the insula a lot more clearly. Now we can see the anterior short gyri over here and the posterior long gyri, which are present more posteriorly over here. Again, you can use a thick and thin rule to identify the pre and the post central gyrus. This will be the supramarginal gyrus over here. This is still the inferior frontal, and this will be the middle frontal gyrus over here. Okay. So as you come closer to the midline, okay, so this here is the superior frontal sulcus. So above this, you can still see some gray matter. So this is superior frontal gyrus, and this is your middle frontal gyrus. So superior frontal sulcus is going to go and end in the precentral sulcus. So you know that this is the precentral sulcus. So it should be your precentral gyrus and your postcentral gyrus. So one more way to identify on sagittal imaging how you can make out the pre and the postcentral. So look for the superior frontal sulcus. Look for it ending in the precentral sulcus, and then identify the pre and the postcentral gyrus. Another way is obviously look at the thick and thin sign all over again. Okay. Then, apart from that, we're able to make out the atrium of the lateral ventricle now with its choroid plexus. Apart from this very strange, long gray matter running along the temporal horn. So this is your hippocampus running within the temporal horn. This here is your collateral sulcus. Apart from that, here we have the Sylvian fissure. Just the gray matter which connects to the head of the hippocampus is the amygdala, located over here. And this here, just above the head in the amygdala, is a very important structure known as the stem of the temporal lobe. So the stem of the temporal lobe provides the white matter fibers running between the temporal lobe and the frontal lobe over here. So this is the stem of the temporal lobe. This here is the amygdala, and this here is the head of the hippocampus. Okay, now you're seeing a very big gray matter located centrally. And there's a very easy tendency to think that this is the thalamus. But remember that this is quite lateral view. This is the first gray matter we're seeing while coming medially. The first gray matter you see that when you're coming medially is actually going to be the putamen. So this big structure over here is the putamen. Okay, and this here is the anterior commissure running below that. Okay, so at the next cut, again we can identify with the thick thin sign. This is the pre and the post central gyrus. Okay, so once we have got that out of the way, let's look at the other structures. You have to identify, as I said, the Sylvian fissure and the tentorium. So this here is the tentorium. The tentorium will appear T1 slightly hyperintense and T2 hypointense, as you can see over here. Okay, so at this more medial cut, what are the things we can see? So we can see the atrium of the temporal horn. You can also see the occipital horn over here. This here is the calcarine fissure. So this is the calcarine fissure which is separating the parietal lobe and the occipital lobe over here. You have the hippocampus running along the temporal lobe. You have the parahippocampal gyrus located over here. Okay, and above the hippocampus, you have a lot of gray matter. Okay, but again, this is still the amygdala itself. This is still the putamen. And this is the anterior commissure over here. These are a few things that you can identify on the SAG images. On the more medial cut, things become a little... So as a very important thing to realize is, as you go more and more medially, since your pre and post central gyri are slanting backwards, the more lateral you are, the more anterior they will appear. The more medial you go, the more posterior they will appear. So now we can see that they're looking a little bit more posterior. So this is the pre and your post central gyrus. Okay, apart from that, we know that this is the tentorium over here. Okay, apart from that, we're able to make out this is the lateral ventricle. This is the occipital horn. This is the calcarine sulcus over here. Okay, then next, after the putamen, this was actually the putamen, and this is your amygdala still. Okay, so after the putamen ends, you'll be able to see the C-shaped structure which is made of grey matter, and that is your caudate nucleus. This other area of grey matter is the pulvinar of the thalamus. So in this cut, we're able to make out the caudate, the putamen, and the thalamus over here, the amygdala, the pre and the post-central gyrus. Okay, so as we come closer and closer to the midline, the structures become more and more obvious and a lot easier to identify. So again, thick, thin, you've got the pre and the post central gyri. Okay, another way to identify this would be using the cingulate sulcus. So as we're getting closer and closer to the midline, the cingulate sulcus will become more and more obvious. So this is a cingulate. The cingulate will turn up and form the pars marginalis. The pars marginalis will bound the paracentral lobule anteriorly. So this is the paracentral lobule. The paracentral lobule is made up of nothing but the pre and the postcentral gyri. This area would be the precuneus and this area would be the cuneus. This is the calcarine sulcus. Okay, so a few very obvious things we can make out. Okay, then another important rule that we have already discussed with axial imaging is above the calcarine sulcus, you will have the cingulate, and below the calcarine sulcus, you'll have the lingual gyrus. So this here is the lingual gyrus, and this here is the cingulate isthmus. So you can make out that this gyrus here, above the corpus callosum, below the cingulate sulcus, is your cingulate gyrus. It wraps around like a C and comes here behind the splenium of the corpus callosum. And this area behind the splenium of the corpus callosum is what is the isthmus. Okay, so you have the calcarine sulcus. Above that you have the isthmus, and below that is the lingual gyrus. You have seen the splenium. This other structure arising from the corpus callosum and running into the lateral ventricle is your fornix over here. This here is the pulvinar of the thalamus. Okay. This here is the caudate nucleus that we had seen previously. That is still a little bit part of the lateral ventricle floor. Over here, we know that the caudate will connect to the putamen using the nucleus accumbens. This will be a lot more clear when we come to coronal imaging. But, so this grey matter located between the caudate and the putamen inferiorly is the nucleus accumbens. So you can make it out over here. Over here, you can also make out the T1 hyperintense and T2 hypointense structure. That is the optic tract over here. Apart from that, there's a few more structures we can see a little bit more clearly in T2. There's a subthalamic nucleus located over here on T1. And the substantia nigra located over here on T1. Okay, so not very difficult, but a few important structures you can pick up. The cingulate sulcus, pars marginalis, the precentral and the postcentral gyrus, the paracentral lobule, the precuneus, the cuneus, the cingulate the calcarine sulcus, the isthmus of the cingulate, the lingual gyrus, the splenium, the fornix over here, the pulvinar. This is the midbrain. This is the subthalamic nucleus, the substantia nigra over here. Not very clearly seen, better seen on T2. The optic tract over here, the nucleus accumbens over here, and the caudate over here. Okay. Apart from that, you can slightly make out a little bit of the border of the corpus callosum. Okay, coming next to almost the midline cut. Okay, a few very obvious things here. Again, you've got the corpus callosum. Thick and thin side will help you still identify the pre and the post central. So will the pars marginalis over here. So most likely it is this and this, as this is the pars marginalis. Next, you've got the inferior and the superior colliculi on the brainstem. This is the superior cerebellar peduncle over here. This is the optic tract. This here, which is slightly T1 hyperintense, is the pituitary gland. This very long gyrus along the orbital surface is the gyrus rectus. This T1 hyperintense structure running at the floor of the lateral ventricle and at the anterior border of the third ventricle almost is your anterior commissure. Okay, so now coming to basically what is the midline cut of this sagittal section. We have the corpus callosum. We're able to see very clearly the fornix over here. You have the septum pellucidum in this region. You will have the thalamus here with the massa intermedia. You will have the region of the hypothalamus here. This is the optic tract. This is the mammillary body over here. This here again is a T1 hyperintense structure. So that is your posterior commissure over here. This is the 10th. This is the cerebellum. The fourth ventricle, the superior cerebellar peduncle. This structure over here running like this is T1 iso intense, but as we can see on T2, it is quite hypo. This is a blood vessel. This is the internal cerebral vein forming the vein of Cannon over here. Okay, so this is the proper midline cut. We're able to make out the third ventricle clearly, the massa intermedia. This here we can make out the posterior commissure here and the anterior commissure over here. The optic tract. This is the mammillary body. This is the floor of the third ventricle with the infundibulum and the pituitary gland over here and the aqueduct being present over here. So this is about the sagittal sections. The final discussion would be on the coronal sections, and we can use a lot of the anatomy that we've already learned with the axial and the sagittals to really understand what is happening with the coronal imaging. It can get slightly complicated, but if we remember whatever has happened with the prior two sections, we can easily pick up as to what is happening with coronal imaging as well. Right, so this is coronal imaging running from anterior to posteriorly. Again, T1 images on the left side and T2 images on the right side. Okay, so we know that the superior frontal gyrus runs all the way from the inferior to the superior surface. So this first thing that we are seeing here is the superior frontal gyrus. This will be the middle frontal gyrus. Okay, so that is very easy to notice. Okay, apart from that, here this is the cingulate sulcus, and this is the rostral sulcus. There's something known as a rostral gyrus which exists on the medial surface. So here you have the cingulate gyrus, below which you get the rostral gyrus. This is the superior frontal gyrus. Okay, as we come inferiorly, below the rostral sulcus, we will get the gyrus rectus. Next to the gyrus rectus, you have the olfactory sulcus. And next to the olfactory sulcus, you have all the orbital gyri, the anterior, medial, posterior, and lateral. In T2 imaging, you can identify a few more structures. So here, running in the olfactory sulcus are your olfactory bulbs on both sides. In the orbit, you can also make out the optic nerve over here. So the optic nerve itself is T2 hyperintense, but the CSF sheath around it is T2 hyperintense. Okay, so just a quick revision. This is the superior frontal gyrus over here. This is the cingulate gyrus, cingulate sulcus over here. You've got the rostral gyri over here, the rostral sulcus over here. This is the gyrus rectus, the olfactory sulcus, and then your orbital gyri. This next image goes further more posteriorly. So this is the superior frontal gyrus. This is your middle frontal gyrus, and this is your inferior frontal gyrus. This is your cingulate sulcus. This entire long segment is the cingulate gyrus. Then you have the rostral gyrus over here, and then you have the gyrus rectus over here. This is the olfactory sulcus over here. Okay, as we go farther posteriorly, we're able to see the cingulate, and there's a bridge which is connecting both sides. So we know that the only bridge connecting both sides would be a commissural tract, and this commissural tract is obviously the corpus callosum. This is the genome of the corpus callosum located over here. So this is the first cut where we are able to see the corpus callosum. This is the genome of the corpus callosum. Just above the corpus callosum and just below, both we're able to see there are T2 hypotenuse structures. This is the ACs wrapping around the genome. So they're running below the genome, and then they wrap around genome and run above the genome. So this is the same ACS. You're running below first and then above the genome. Okay, the further posteriorly we go, we're able to make out the corpus callosum a lot more clearly. So this will be more posterior to the genome, so there will be more of the body of the corpus callosum. Above the corpus callosum, you will have the ACS running here, and then you have the cingulate gyrus over here, and the cingulate sulcus. This is the most important structures to identify. We're also able to see on T2 imaging that now we're starting to form the orbital apex, and also starting to see a part of the temporal lobe appearing now. Right, so in the next cut, everything becomes a little bit more obvious. So you have the temporal lobe which has become prominent now. You have the sylvian fissure separating the temporal lobe and the frontal lobe on both sides. Okay. So then again, you have the same structures. You have the corpus callosum. This is the body of the corpus callosum now forming the roof of both lateral ventricles over here. On the side of both lateral ventricles, we know there are two C-shaped structures which run, forming grey matter. This is a caudate nuclei on both sides. They form the floor and the lateral wall of the lateral ventricle. Okay, so this here is the genome. This is the body, and this is the rostrum, the part which goes down around the frontal horn. Okay. Then below that, below the corpus callosum, there's a subcallosal area over here. This is the insular cortex, and this is the temporal lobe over here. This here again are the ACS running above the corpus callosum. Okay. As we go more and more posteriorly, we're able to see a few more structures. The lateral ventricle becomes more clearly defined. You're able to pick up on the frontal horns and the septum pellucidum, which separates both the frontal horns. Above the septum pellucidum, you have the corpus callosum body running, above which you have the interhemispheric fissure with its 8 ACA branches, which are very obviously divided into the pericallosal and the callosomarginal now. The pericallosal runs just above the corpus callosum, and the callosomarginal runs in the callosal sulcus. So in the cingulate sulcus. Okay. Apart from that, we have a few other important structures that we can make out at this level. So here we have the optic tract. So this is the optic nerve. This is a cisternal segment of the optic nerve. Okay, running intracranially. The next cut, it should join and form the optic chiasm. This handlebar-shaped structure is the anterior commissure. Here, you're going to have this is the third ventricle, and the next cut, the lateral ventricle will join the third ventricle to the foramina Monro. Wrapping around the foramina Monro, there are two structures. That is the anterior pillars of the fornix. So this is the anterior pillars of the fornix. The third ventricle, this is septum pellucidum. You also have the caudate nucleus over here. Okay, and then you have the putamen over here. And as we have discussed 2 or 3 times now, the caudate and the putamen are joined to each other inferiorly through the nucleus accumbens. Okay, and this will be the anterior limb of the internal capsule. The anterior limb of the internal capsule occurs at the level of the putamen and the caudate. The posterior limb of the internal capsule occurs at the level of the putamen and the thalamus. Okay, so at the level of caudate and putamen, you will get the anterior limb of the internal capsule. This here, after the putamen, is your external capsule, then your claustrum, and then your extreme capsule. This is superior temporal gyrus and the middle temporal gyrus. This here is another important sulcus when it comes to the temporal lobe. This is known as the rhinal sulcus. The rhinal sulcus demarcates the entorhinal cortex over here, which is also a very important cortex. So this is the entorhinal cortex. You have the rhinal sulcus over here. Okay, as we go further deep, we can see that this is the optic chiasm, which is formed by the optic nerves over here. Optic chiasm is quite often the T2 imaging also. Apart from that, we have the corpus callosum. We have the cingulate gyrus, the cingulate sulcus on both sides, the ACH that we have already picked up. You have the caudate forming the lateral wall border of the front horns, the septum pellucidum, the anterior pillars of the fornix running over here. Okay. Then you have the putamen, the nucleus accumbens on both sides over here. Okay, now we're also able to see a structure running between the temporal and the frontal lobe. So this is your temporal stem. So we can make out. There's also a very big mass of grey matter over here. So this is the amygdala. Again, rhinal sulcus, the entorhinal cortex. And this T1 hyper intense region over here is the cavernous sinus. You can make out the cavernous ICS here, and this here is the supraclinoid ICA over here. Okay, so as we go on more and more posteriorly, we can make out a few other structures. The optic chiasm is giving rise to the optic tracts posteriorly. You have the sylvian fissure, you have the opercula over here, the frontal operculum, the temporal operculum, the insular cortex, which is very obvious over here, the caudate, the putamen, and the nucleus accumbens are still obvious over here. This would be the corona radiata over here. Right. So as we go more and more posteriorly, there are a few structures that we can see further. So this is still the cavernous sinus over here. Okay, so again, here is the cavernous sinus. We can see there's a structure coming out of the cavernous sinus and running inferiorly, and there's a hole in the bone. This T1 hypointense and T2 hypointense region on both sides of the bone. This is the petrous bone. This is the sphenoid bone through which is a hole, through which there's a structure running through this hole. This hole is the foramen ovale over here, and through which the mandibular nerve is running out from the lateral bottom of the cavernous sinus into the infratemporal fossa over here. So we can actually tell both on T1, this is the foramen ovale, this is the mandibular nerve, and on T2 also, this is the foramen ovale, and this is the mandibular nerve. Okay. Apart from that, this here is the infundibulum, going into forming the pituitary gland. This is the optic tracts on both sides. This is the fornix. This is the hypothalamus, not the fornix. This here is the fornix, septum pellucidum, caudate, and putamen. This here would be the internal capsule anterior limb. As we go further posteriorly, again, we can see the temporal stem, the amygdala. We are still going to call this grey matter the amygdala because until we see the temporal horn, we're not going to call this as the hippocampus. This here is the uncus. This is the entorhinal cortex as we have discussed previously. This is the third ventricle, and this is the hypothalamus. As we go posteriorly, we can make out now that we can see the temporal horn. Okay, the temporal horn on its floor will develop a grey matter collection that is known as the hippocampus. So we're not able to see that yet. The hippocampus, even though the temporal horn is visible, the hippocampus is still not visible. This here is a temporal stem, and this here is the amygdala, temporal horn. This is the entorhinal complex over here. This is the optic tracts. So at this level, we're able to see two important sulci. So this is the medial one is the collateral sulcus, and the lateral one is the occipitotemporal sulcus, separating the inferior temporal gyrus and the occipitotemporal or fusiform gyrus. The sulcus separating the occipitotemporal gyrus and the parahippocampal gyrus is your collateral sulcus over here. So we can make out that this is the parahippocampal gyrus. This is the amygdala, as we've already discussed. Okay, now we can see a clear track between the frontal horns and the third ventricle. So this is the foramen of Monro over here. At the level of foramen of Monro, the internal capsule will correspond to the genosis. Here you would find the geno of the internal capsule. So any cuts posterior to this, we would have the posterior limb of the internal capsule and not the anterior limb. Okay, so this is superior frontal gyrus, the middle frontal gyrus, and the inferior frontal gyrus. Superior temporal, middle temporal, and inferior temporal gyrus. This is your occipitotemporal fusiform gyrus, and this is your parahippocampal gyrus and your collateral sulcus. So these are all the things we possibly did not know how to identify before, but now because of the simple normal anatomy of this region, we can pick up that these different structures exist. Okay, so apart from that, now we're able to see there is some grey matter located along the floor of the temporal horn. So this here is your hippocampus. You can make it out here also. This folded structure over here is the hippocampus. This is the amygdala and this is the hippocampus, this folded structure here. This here is the optic tracts, and this would be the hypothalamus over here. Okay, so as we go further posteriorly, if we can make out a lot of the same structures, the hippocampus is a lot more obvious now over here in both T1 and T2 imaging. Just below that, you have the parahippocampal gyrus and the collateral sulcus on both sides. You can make out the mammillary bodies now. The body of the lateral ventricles on both sides. And now you'll start seeing parts of the thalamus on both sides of the third ventricle also. And between the putamen and the thalamus, you'll find the posterior limb of the internal capsule over here. There are two structures you can see within the suprasellar cistern, one here and one here. So the inferior one corresponds to this hypointensity on the T2 image. So that's most likely the PCOM. And superiorly, you have the third nerve over here. Okay. So the more posterior we go, things get slightly more obvious. You get the brainstem. This is the beginning of the aqueduct. This here is the fornix over here. This is the thalamus. This here is the hippocampus. You can still see the body of the hippocampus over here. Here we have the cerebral peduncle going in from the internal capsule into the brainstem. Just above that, we have the red nucleus. It's obvious over here. And just below that, you have the substantia nigra over here. Okay, so just the last few cuts left, and we'll wind up this session. So here is the parahippocampal gyrus, the hippocampus, the cerebral aqueduct. This is the optic tract over here. This is the fornix. These, if you can see, corresponding to the images on T2 are the internal cerebral veins. This is the interhemispheric fissure. This is the cingulate gyrus. The more posteriorly we go, we can pick up a few more structures. So this here is a tentorium. This here is the beginning of the fifth nerve arising from the middle of the pons. This is the cerebral peduncle or the crus cerebri. This here now would be the posterior commissure. And this would be the habenula nucleus. Lot more obvious now, the posterior commissure, which forms the posterior boundary of the aqueduct over here. This is the fifth nerve exiting. This here is the pineal gland. And this here are your internal cerebral veins. Further posteriorly, you can see the seventh and the eighth complex also exiting from the pontomedullary junction. This is the medulla. And this here is the jugular bulb. These are your superior colliculi. This is the periaqueductal gray. This is the pulvinar of the thalamus over here. Okay, so again, the more posterior you go, just remember the most basic anatomy, and that will help you figure out what are the different structures. The superior, middle, frontal gyrus. At this level, most likely the inferior frontal gyrus has ended at the level of the atrium, and you're going to be picking up on the precentral and the postcentral gyrus on the other hand instead. This is a cingulate gyrus over here, and this here is still the hippocampal formation. This is the hippocampal tail over here. The more posterior we go, the lateral ventricle will start ending. So this is the splenium of the corpus callosum running here. And this very wide band below that is the hippocampal commissure here, connecting both the hippocampi on both sides. Okay, this is the fourth ventricle, and this is the superior cerebellar peduncles. These are the middle cerebellar peduncles, and these are the inferior cerebellar peduncles on both sides. Okay, the more posteriorly we come, now we can see the tentorium clearly. This is the transverse sigmoid junction. This is the sigmoid sinus. Okay, this is the collateral sulcus over here, almost trying to reach up to the atrium. This is the atrium. This is the cingulate over here. The more posteriorly become, the calcareous sulcus becomes a lot more obvious. There really isn't much more to identify posteriorly. There really aren't any landmarks that will help you figure out what are the different gyri. Just have to pick up on the calcareous sulcus and the occipital horn and the cingulate. There's really not much else you can identify over here. Okay, so all you can say is that this is most likely parietal, this is most likely occipital, but there's really no landmarks here to really pick that up. Okay, so you still have the calcareous sulcus and this to really help you figure it out, but apart from that, there's really not much else that you can do. Remember, below the calcareous sulcus, you have the lingual, and above the calcareous sulcus, you'll have the cingulate. Right. So, if we can try and identify this structure, that would be great. You can leave a message in the chat box if you wish. Yeah, so this is the fornix. Okay, so this is the anterior columns of the fornix wrapping around the foramen of Monro. Lateral ventricle, septum pellucidum, and the caudate nucleus on both sides. Okay, can we identify this structure over here? Yeah, so this is the infundibulum, which is extending from the floor of the third ventricle into the pituitary gland. Other structures of note here are the ICAs on both sides, the very obvious T1 hyperintense optic chiasm and optic nerves. Right. So that is all for today's lecture. The next part will consist of the cerebellum, and we'll also discuss a little bit of the CT anatomy as well. Thank you so much for attending.